The ambiguous case only happens with the law of signs, which we began on Friday or Thursday of last week. So the only time that you'll have to really worry about ambiguous cases with the law of signs. And I'm actually going to go to the next slide. This was a question I had on last week that was, how do you solve a triangle that's not right? I took it off because you guys, it wasn't in Algebra 2 last year. It had previously been in Algebra 2, and then it was not in the new textbook, so they took it out. So my last year Algebra 2 students had never seen law of sines and law of cosines before, whereas in the past that had always been the case. So the answer to the question, how do you solve a triangle that is not right? One of the answers is the law of sines. And that's what you started practicing. You uncovered the law of sines on your own on Friday, and you started practicing it. And all the problems that you did, I'm calling it Friday, but you know me, I mean Thursday. From Thursday, all the problems that you did, if you looked at the given information, the information that was provided to you, it fit one of these things. You either had angle, side, angle, or angle, angle, side. And you guys remember those things from geometry? Okay, and we kind of talked about them when we were doing the area formula. The area formula for law of sines involves side, angle, side. But if we look up here at the board where Allie asked that homework question with the tree, we knew 94, we knew 40 meters, and we knew 30 degrees. So we had a case there with angle, side, angle. Two angles and an included side, the side in between them. We could also use law of sines if we had angle, angle, side. And both of those, when I give you two angles, that really means you actually know what. If you know two angles, you actually know three angles, right? Like there's not much work that needs to be done to find that very first angle, 180 minus the other two. So when you have the angles and just one of the sides, you easily are going to use the law of sines, and you did that already on your homework assignment. Okay. Now, that's not the only time you can use the law of sines. You can also use the law of sines if you are given at the very beginning two sides and a non-included angle. So side, side angle, which that word spells that word, right? So in geometry, your teacher probably told you never spell the bad word, forwards or backwards. That was not a way to prove triangles were congruent. To have side-side angle, that's not enough information. And so you never really worked with anything that was side-side angle before. What we're going to say is today, if you're given this bit of information, side-side angle, this is going to be the ambiguous case. So now, I would start every problem that I do going forward when I write down the information that's given to me, or I draw my triangle and I label the triangle with the parts, I would figure out, what do I have? Do I have angle, side, angle? Do I have angle, angle, side? Or do I have side, side, angle? And anytime I come across side, side, angle, light bulb comes on, this is that ambiguous case. And I'm going to illustrate the ambiguous case here on GeoGebra in just a minute. Okay. So this will also be really helpful because tomorrow when we talk about law of cosines, you can use law of cosines when you have side, 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 and side, angle, side. So by knowing what your given information is, it kind of dictates to you what rule or what theorem you can use to solve the triangle. Okay, so we're going to look at a GeoGebra file. When I post my notes online after school today, this slide will be included in the notes. So if you want to play around with the GeoGebra worksheet on your own, you can type this in and go to that location on the web. Okay, sorry, just getting it ready. Okay, so
So here's a visual of the ambiguous case. You don't need to write anything down, just kind of look and see what's happening here. Let's see if I can make that a little bigger. Not really, just the words. Okay, so here's what we have on the GeoGebra file, and I'll try to kind of walk you through so you can see everything that's provided. Okay, now I can change this to be any problem that I want. These things over here are called sliders, and the top one is for angle B. It looks like a beta, but it's saying that beta is now set at 47 degrees. I can make it whatever I want. Okay, and then it also has one for side B, which would be across from angle B. So here's my angle B right here, and then I have this side B that I would know. Okay. And I also have side C. So angle A is up at the top, so like this side down here that doesn't exist right now, that's side A. And so wherever I make my triangle, I'm going to have an angle C over here, like towards the right side, and then that side opposite it is going to be side C. So I have two sides and an angle. And when I graph them, note that it's a case of side, side, angle. The angle is not included in between the two sides or formed by the two sides. So that's important in the ambiguous case. Because if it's side, angle, side, it would be something different. Okay, so it's side, side, angle. I currently have angle B set to 47, side C is 7, and then side B is 10.5. Okay, and so you can see over here on my 10.5 side, what I want to do is, these things are fixed. So as I move this side, it doesn't change length. It's still 10.5. I'm not making it shorter or longer. It's always set at 10.5. This side over here is set at 7, and it's not going to change. And I've been given an angle of 47 degrees, so that's also not going to change at all. Okay. My job is to construct a triangle. Okay. And so I have this dotted line right here is extending out towards infinity, sort of like a ray. And what I need is this side that is fixed, 10.5, to meet that ray so that I would actually form a 47 degree angle with the side that is 7 and then this other side A. Okay. So I could put the endpoint right there, and where this red X is, that would be where angle C is. Okay. And do you agree that we have created a triangle with those two sides and that angle? Okay. Now, I technically should be able to like move this side all over, but over here, I'm not going to be able to create the same triangle because an angle B wouldn't be 47 degrees. It'd be on the other side, and it'd be something that is larger than 47. So in this case, I really only have one triangle that I could make. Okay, and that's to put that line, or that red X right there on that line that is dotted. Okay. Okay, now, if I change something, so I could change all of them if I wanted to. I'm really only going to change that side that's moving around. If I change that side, and let's say I make that side, so I keep my 47 degree angle, I keep my 7 side, and then I change that side so that it's only 2.8. Am I going to be able to make a triangle? Heck no. Okay. No matter where I swing that side, if that side is fixed at 2.8, there's no way for me to build a triangle with a side 2.8, a side 7, and an angle 47. Okay? So this is what's ambiguous. When you get the side-side angle, is there a triangle or is there no triangle? It's unclear with just the numbers. So we're going to do the math and we're going to find out when there is no triangle and when there is a triangle. Now, it's even more ambiguous than just no triangle or one triangle. If I get the side length just right in a certain sort of range, there is a possibility for me to create sometimes two triangles. So do you agree that if I change that side length to be 5.6 and made it a little bit longer than it was, I can create a triangle again? Okay, so I've created this triangle here. Angle B is 47, side is 7, side is 5.6.
case where that one side link was 2.8, switch the 7 and the 2.8 to create.
It would be a totally different side-side angle. So the whole point about side-side angle is that they're fixed. So side was 2.8, side was 7, angle was 47. I couldn't change them, switch them around. Yes, then it would be a different triangle, but then it would be a different problem. Okay. So here I have one triangle. Now if I continue to move this side, notice I'm not connecting just perfectly with that, oops, sorry, dotted line, so I'm not creating a triangle, but as I swing it around, I meet up with that dotted line again. Have I just created another triangle? Yes, I have created a second triangle. It has an angle B of 47 degrees, it has a side length 7, and it has a side of 5.6. So I'm not changing any of those pieces of information that were given to me, but I'm now creating two triangles. So here's the deal with ambiguous case. You could have no triangle at all. You could have one triangle, or you could have two triangles. And it will only happen when you're given information is side, side, angle. So now you need to be on the lookout for what your given information represented. Do you have a side-side angle? You need to check for ambiguous case. Before I leave this, the one last thing I want to do is point out to you, I'm going to go back to that very first triangle I made. Here's where point C is. Okay. We could estimate this angle for C, but at the very least you could say what to me about the angle. It could be classified as what type of angle. It's acute, it's less than 90. If I had to estimate it, I might say like maybe 60 or 70 degrees. Okay. When I swing that side over, and I make connection with that line again, so I'm still creating a triangle, what would you say about the new value of C? It's now obtuse. And even more specifically, if I estimate that angle right there, I might estimate it at like 120 or 130. It's actually going to be the supplement to the acute angle. So that's how we're going to be able to find both triangles, because that angle that you're going to find at the very beginning is either that acute angle or its supplement, if there are two triangles. And so keep that in the back of your mind, that angle that's ambiguous, or that could be two different angles, they're supplements of each other. So there's a connection there. Okay, so nothing really is brand new. The law of signs is still the law of signs. Nothing has changed. It's just going to be the way we work a problem. Okay, so here's a problem. You can draw any looking triangle that you want. Obviously, mine is not drawn to scale. That angle B is not 33 degrees in my picture. Angle B is 33 degrees, side B is 14, and side A is 23. And really, the only thing that I would be asking you to do in this section of your notes, in this section of your assignment, is now start looking for what type of information was given to you. Okay. So when I look at this triangle, do you see how it would be angle, side, side? Or side-side angle. Okay, I'm going to write side-side angle so I don't write that word on the board. But the one angle that you're given is not included, so it's not side angle side, it's side-side angle. Can you start setting up law of signs with this solving? Please do so. As I was walking around, peering over in South Carey, immediately write down that very first ratio, sine 33 over 14. You got to look for that pair in order to be able to do law of signs, where you know the corresponding angle and side, because you have to know one full ratio. So we've got that. And then we set it equal to sine A over 23. Solve, cross multiply, go, do it. I'll show a little bit more work than I usually will. So I cross multiply 14 sine A equals 23 times sine 33. Then I'm going to divide by 14 on both sides. So now I have this statement sine A equals 23 times sine 33 divided by 14. How are you going to get A all by itself? You got to do inverse sine, right? So I'm going to go ahead and write on here that at this point, I'm going to go ahead and take the arc sine of both sides. Now you can write arc sine or you can do the inverse sine with the -1. Either one is acceptable, but I have to do it to both sides. So that is a little bit different in terms of solving. We're going to have to use the inverse trig function in order to be able to get an angle. But note that I don't really need to do any kind of rounding, right? If you want to, you can type into your calculator. But I can type this all into my calculator all at once. I'm going to do second sine to get the inverse sine. And then I just need to type in 23 sine 33 divided by 14. So 23 sine 33, close my parentheses there, divided by 14. And my angle must have been 63.48. Y'all okay with how I solve for my angle? Now, I will show you a nice handy key so like you can avoid rounding. Oops. Suppose you typed in 23 times sine 33 divided by 14 and you get this decimal 0.8947 and so on and so on. What I would encourage you to do is try to avoid rounding for as long as possible, because as soon as you start rounding, everything else in your answer is now a rounded answer, and so it becomes more and more off. Okay. Here's a nice tool in the calculator. If you went ahead and evaluated this right side and got a decimal, and then you want to take the inverse sine, do second sine. And one option would be to type in all those numbers. The other option is second negative. When you type second negative, right above the negative sign, it says ANS. It means answer. And that button will pull up the previous answer. So when it says the inverse sine of ANS on mine, the line right above is 0.894764129. The calculator is going to put all that in for me, so I don't have to type it out. And so if I do the inverse sine of that answer, I'm going to get that full answer, 63.48. Okay, rounded. Okay. I'm going to write 63.48, but I'm going to continue to sort of use my answer key so I can avoid rounding for as long as possible. If you know that A is 63.48, you can now find angle C. So you just do 180 minus angle B was 33, angle A is 63.48. And so I can type that into my calculator. I'm going to do 180 minus 33. And then again, instead of having to type in 63.48 or all those other decimals if I don't want to round, just do second negative, and I get a non-rounded answer. Okay, so it's taking the line previous, which was that line I wanted. You have to make sure you have the answer there that you want to use, right? But then I can plug that in. So then C would be 83.52 degrees. Are we okay with this? Okay. So now I have angle A, angle C. I just need to find side C, right? Okay. So I'm going back to my picture. Move my calculator. To find side C, I'd use angle C, which is 83.52, and then I would go back to that ratio I stole from Carrie's work, sine 33 over 14. Okay. So So set it up and solve it. Sine 33 over 14 is equal to the sine of 83.52 divided by c. Cross multiply, divide, and then you've just got to type it into your calculator. Because I've been keeping track and not rounding my answers, I'm able to do that again. Oops, sorry. With this 83.52 number, I can do 14 times sine of my answer and divide by sine of 33. So I get 25.54. If you use a rounded answer, you're probably not going to be off by that much. Maybe it's off in the hundredths place, if at all. But I would encourage you, like, as you progress into higher and higher levels of math, you want to stop using numbers and decimals for as long as possible, because you don't want to round answers. You want to have exact answers at the very end. So I come up with something like C equals 25.54. Any questions on that work that need to be addressed? So a little bit different right here. In order, if you only have one angle, that means at some point you're going to have to do an inverse trig function to find the second angle. Okay, so that's kind of a guarantee that you'll have to do that. Now, remember that at the very beginning, I labeled this as side-side angle. So I've got little warning bells off in my head. Side-side angle, that's that special ambiguous case. I am going to assume that all of this work I just did was for my first triangle. It worked out, I got a triangle. I'm going to assume that I have a second triangle. Will that always be the case? No, sometimes it will work out so that you'll have only one single triangle. Okay, but I'm going to assume that there's a second triangle. And so I'm going to begin the work to find out what that second triangle is. Morning. Thanks, guys. In order to find my second triangle, this is what I need to do. I got to go to the very first angle that I found. What was the very first angle that I found in my other work? 63.48. Find the supplement to that angle. Do not go to the second angle that you found. That's not the angle that we're talking about. Go to the first angle that you found. Okay. So our first angle was 63.48. If a second triangle exists, then angle A will be the supplement to 63.48. Now, you can decide in your calculator if you want to get an exact answer. You might go back and retype in the information like arcsine 23 sine of 33 divided by 14. So that I get the 63.48, and then if I want an exact answer, I do 180 minus that, which is 116.52. Okay, you're going to get 116.52 if you subtract 63.48. But now I have this answer recorded in my calculator, and I'll be able to use the non-rounded answer going forward. So 116.52. And then you just repeat the same process. So can you find the other angle and can you find the missing side? Please do so. We'll kind of compare answers and see if we agree. So once you find that supplement, then you act like that's a new angle, and you go back and you find a new angle C and a new side C. Was anybody else gone on Thursday? You were gone on Thursday. This was an activity we did to uncover the last time. Not required. You already got it. Oh, that's an angle. No. What's the new angle C measurement? If it exists? 30, sorry, can't hear you. Oh, cannot hear you. Say it out loud. 30.48. Then you use that to set up a proportion. Okay, so remember, Carrie used sine of 33 over 14. That's the one ratio we know. And then we'll say the sine of 30.48 over C. Anybody get a value for C yet? 13.05? Anybody agree with that? I need a second before we can move on. 0.04? So we agree with 13, but we're maybe arguing the rounding. Carrie?
On a test, if we're like a point decimal away, is that going to be taken off with bathroom? Okay.
You should follow rounding rules. Like if you do it on every single problem and you don't round correctly, I mean, maybe then at that point I'll take off. But like if you're just accidentally one time don't round. The issue is also that like if you round early, you're going to be off, perhaps. So to avoid that, use the answer button. But no, usually I wouldn't take off for something so small. Okay, do we have any questions about this before we leave? Yes.
How do we know if the second triangle like doesn't exist?
Oh, great question. That's like my next problem. I could tell you, I could ruin it right now, but I'm gonna let you uncover how that works. So I think this is a great way to leave this slide and just say, if you recognize side-to-side angle, you will assume that there are two triangles. Just always assume that there are two triangles, do the work for two triangles, and now we're going to look at an example where there are not two triangles. Okay, so I'm ruining the answer, but you'll get to see why that works. Okay, so here's example 2. This time I've got angle B is 79 degrees, side B is 16, and side C is 9. So I'm going to do less work on the board. I need you guys to be doing the work in your notebook. Please look for, if there is a first triangle, what are the measurements of the first triangle? Did anybody get a angle measure for C yet? 33.52 degrees. So what's angle A?
67.9.
67.48?
Yeah.
And what's side C? 9?
Yeah.
Oh, sorry, side A.
15.06.
15.06. Are we in agreement with those numbers? Can you find a second triangle that you know doesn't exist, but can you find out why? And talk to your group members if you don't remember. How do you get started on that second triangle? What do you do first? Try to tell me what I'm going to do first to find my second triangle.
You take C because that's the first angle that you found, and you subtract from 180.
Okay, go to your first angle that you found and find its supplement. So you got to start at the very beginning, change that very first angle. And what is that new angle C? 146.48? Did I get that right? Okay. You find your error? What did you do?
I calculated something of sine
Oh. No. Go to the first angle that you found, right? Okay. Then you complete regular work, right? So just like I would find A, I would do 180 minus 146.48 minus 79, and you're going to be very alarmed at that moment because we already know 180 minus 146.48 is that 33.52, and if I try to take away 79 from that, what's going to happen? It's going to be some kind of negative angle. In a geometric triangle, can you have a negative angle? No, we talked about negative angles on the coordinate plane when we're talking about angles in standard position. That is not the same thing as a regular shaped triangle. So just like in geometry, negative angles would be a no-go. This is the moment you just stop. Abort your mission, move on. There is no second triangle, there's only one. But you gotta have the right work. So that is something that happens. I often also have students find the supplement of their second angle. That would also be wrong. Okay, you're answering a different problem than you are if you're working with either angle A or angle B. So kind of be aware of that. Are we okay with that? Okay, then we have one other case to look at, correct? So that you're prepared for this when it happens. Please set up and solve. If I have triangle ABC and angle C is 85 degrees, side C is 15, and side A is 25. setup should look like what I have on the board, correct? And then at some point, depending on how much you actually have to write out to solve, you work it out. What happens when you do this in your calculator? Domain error. No solution. This is an example where a triangle doesn't actually exist. I've drawn a triangle, but it's not possible to have a triangle with those side lengths and angle measures in those locations. Remember, David thought, well, what if we switched around a couple sides? Maybe a triangle would exist, but then it would be a whole different problem. So here we would say, no solution, no triangle exists, anytime you get that domain error. What that means is this work right here you did, I think last hour somebody figured it was like 1.6. So a sign value can't be more than 1 or less than -1. Think about the sine wave, that's its amplitude, that's its range. So we can't put in numbers that are bigger than that and get answers back out. Okay. Any questions? Okay. At that point, you wouldn't even assume there are two triangles, you would just move on to your next question. 1.66? Yeah. Okay, so here's your homework assignment for this evening. What I would suggest to you is as you work out the homework assignment, be cognizant of this whole, like, what information is given to me? Does it represent an angle, side angle, angle, side, or side, angle? Most of the homework, if not all of it, should be side, angle, but just know, if it's angle, side, angle, you don't have to check for a second triangle, right? We don't have that issue because we're not finding one of the angles to begin with. Okay. So kind of keep that in mind, because then tomorrow when we do log cosines, we add side, angle, side. So part of your job that you'll be practicing and preparing for that quiz, which instead of Wednesday will be on Thursday, is how do you know when to use which tool? And how do you know when you got to check for that second triangle? Right? Those are the things you really want to focus on.